Hello, this is Mr. Huber. In this lesson, we're going to look at a few different aspects of solving equations. We're going to focus on solving something called literal equations, and then we're going to look at applying how we can write equations to some real-world scenarios. So first we want to talk about solving literal equations. These are equations where we're not going to get a value for an answer, but we're going to get an equation for a variable that equals something in terms of another variable. So key concept here is in terms of, okay? We see right here, in terms of other variables. So we're not necessarily going to find out that x equals 5, but we're going to find out that x equals something with y in it or a in it or some other variable. Okay, so again, we're not going to get an answer that's a numeric value, but we're going to get the variable by itself equaling something with other variables still in the solution. All right, so let's see what that looks like here in an example. And keep in mind, we're going to follow the same principles we would have in solving any other equation. We're going to isolate the variable using our inverse operations. So the first example is to solve the equation for x, and we get y minus 2x equals 15. Something that can be helpful here is to rewrite the equation with numbers in it. Let's say that we had the equation 7 minus 2x equals 15. How would we go about solving that? Well, we'd subtract the 7 on both sides. And we'd have minus 2x equals 8. And then we could divide both sides by negative 2 and by negative 2. And we'd end up with x equals negative 4, a value answer. In this other example, we want to look at how we can solve this by subtracting y on both sides. Right? Just like before, we would have subtracted the 7 on both sides. Okay, so now we're subtracting a variable instead of a value. When that cancels out and we still have negative 2x, just like we did in the other equation on the other side, now we're going to have 15 minus y. See, on that first equation we solved, over here, we get negative 2x equals 8, because we could subtract 15 minus 7 and get 8. Now when we do 15 minus y, we're going to leave it as just 15 minus y. And then we can divide by negative 2. Again, just like we did on that equation on the right side, that cancels out and gives us x equals 15 minus y over negative 2. And that would be our answer. Okay? 15 minus y over negative 2. That's x solved for in terms of y, in terms of another variable. Okay? Again, same steps, just instead of subtracting a number, we subtracted a variable. So we can't actually combine the 15 minus y, we just leave it as 15 minus y. Sometimes this comes into play when we're dealing with formulas, okay, like we see in this second example. We're going to solve the formula for r. So in order to get the r by itself, this is 2 times pi times r. This is the formula for circumference. That's the circumference of a circle. Well, maybe we know the circumference and we want to find the radius, the r. What could we do? Well, we could divide both sides by 2 pi and divide both sides by 2 pi. That cancels out, and so we would have c over 2 pi equals r. We solved the formula for r. We know what r is equal to in this formula. Another common example is d equals rt. Distance equals rate times time. Okay? Sometimes we want to find the rate or the time. Well, we can do that. If we want to solve for time, we divide both sides by r. It cancels out. Distance divided by rate would equal time. If we go 500 miles and we're driving 50 miles per hour, that would give us a time of 10 hours. That's how we could find time, the distance divided by the rate. We took this original equation right here. We took this original equation, d equals rt, and we solved it for variables in terms of the other variables. And we could use that then to solve different problems. So again, know how to solve for a variable, even if it's not getting a value answer, but getting that variable solved for in terms of other variables. All right. Let's take a little time to center ourselves here. You see the question at the bottom, you may have noticed already. What is the geographic center of the 50 United States? So all 50, including Alaska and Hawaii, not just the continental. All right. It is somewhere in South Dakota, a little bit north of a town called Belforche. So in the middle of South Dakota is the geographic center of our country. And that was figured out after Hawaii and Alaska were added as states. So an interesting little fact about where the center of geography is for the United States. All right. Sometimes writing equations is useful for modeling situations in the real world. An example we have here. Jim and Lloyd leave school at the same time and ride their bikes in opposite directions. Jim's riding 14 miles per hour and Lloyd is riding 12 miles per hour. How long will it be for them to be 65 miles apart? We're trying to find this 65 miles apart is a distance. We just talked about this a moment ago. We know that distance equals rate times time. So Jim's distance is his rate times time. His rate is 14 miles per hour times time. Lloyd is 12 miles per hour times time. We want to know, and if they're driving in different directions, one's riding this direction, let's say that's Jim, they start here from school, and this is Lloyd going this way, we want to know when this distance from here all the way to here is 65. So we can take the distance Lloyd has driven plus the distance Jim has driven, and that will give us the total distance. So we can do 14t plus 12t. That's the distance for Jim and the distance for Lloyd. Added together, and we want to know when that distance between them is going to be 65 miles. So now we've got an equation we can solve. Using that distance equals rate times time formula, we take their two distances and add them together to get 65. So if we go to solve this, we're going to get 26t equals 65. And then if we take that equation, we divide both sides by 26, we get t equals 2.5. In this case, it's 2.5 hours. So in 2.5 hours, they will be 65 miles apart if they ride at that rate and just keep going in opposite directions. All right. Let's look at another example here, relating back to some geometry and complementary angles. We got to remember what that means. So two angles are complementary. Complementary means that they have a sum of 90. So it means that two angles have a sum, when you add them together, of 90 degrees. So one of the angles is 30 less than twice the other angle. So one angle, we'll call it x, okay, is 30 less than twice the other angle. We can call it y, okay? One angle is 30 less than twice the other angle, okay? We could have two different variables in this, okay? That's not going to work a whole lot. We don't want to write it with two different variables. So we know that one of the angles, okay, is 30 minus 2y. The other angle is just the y. There's our two angles, right? One of them is y. Pick whichever one you want, okay? And the other one is 30 less than twice it. So 2 times y, right? If we look at our examples here, right? One of the angles is y. The other one is 30 less than twice that. Only this isn't going to help us out. If we didn't notice, as you're going through this, if you caught a mistake here, this is not 30 less than twice y. We need to do 2y minus 30. Right? 30 less than something means we're taking the 30 away. So we're taking the 30 away from twice y. And if we add these two angles together, it should come out to 90 because they're complementary. And you can use any variable you want. If you want to use x instead of y, it doesn't matter. The key is when I add these two angles together, okay, I'm going to add these two angles together and I'm going to get 3y minus 30 equals 90. They're complementary, it means they add up to 90. Again, one angle is y, the other one is 30 less than twice it. 30 less than twice that. So those are two angles. Okay. Now if I solve this equation, I'll get 3y equals 120. When I add 30 to both sides, we can write that out, make sure we know where that's coming from. And now if I divide both sides by 3, I'll get y equals 40. This is an important time to make sure we're answering the question. Did I answer the question? No, I did not answer the question yet. Find the measures of both angles. I need to take the 40, I need to plug it in here to both of these. So my two angle measures are going to be 40 degrees, because if I plug 40 in here, y is just 40. And now if I plug y in over here, I'm going to have 2 times y minus 30. So I'm going to have 2 times 40 minus 30. So my other angle is then 50 degrees. 2 times 40 is 80 minus 30. So my two angles are 40 and 50 degrees. Does that make sense? Well, they both add up to 90. That does make sense. Is this angle 30 less than twice the other one? Sure is. 2 times 40 is 80. 30 less than that would be 50. So it looks like I'm on the right track and I've got answers that make sense. Always ask, did I answer the question? Does it make sense? Work on ways that you can use variables to write out expressions and turn those into equations. You got to have an equation to solve for a variable. Okay? And if you're going back to the beginning, remember, when we solve for that variable, we're not always going to get a number. Sometimes we get a variable solved in terms of another variable. So we'll be practicing that and using those skills in terms of some different situations here with equations we can work with and solve.